are recording. This is the South Sound User Group presenting Adron Hall.
So I have quite a few things to talk about. Three specific things to talk about. We're talking about Terraform and Docker for development production environments, specifically around getting a Hasura and Postgres setup up and running, get a little bit of a data model in there, and look at what that API has. It's a great way to get yourself a GraphQL backend based on the core of it being Postgres, so relational database technology that gives you that GraphQL front end. We'll talk about that a little bit. And then we'll play around a little bit with the GraphQL.NET library. I guess that's just what it's called. It's called GraphQL.NET because it's not got a catchy name or anything. And I'll talk a little bit about the libraries and some of the front-end user interfaces that I'm actually doing some stuff. And we'll hit on some talks and shows and Twitch streams that I'll be doing that if you like what you hear here and are interested in this technology, you can join and I will further elaborate for hours and hours and hours and days and days and days and months and months and months. So that's what we're going to talk about. Let's see here. Screen share screen. Desktop too. So now everybody should see a slide deck, an IDE, and an iTerm.
We got you.
Cool. Okay. I always like to make sure. I talked for 10 minutes recently, and I was showing a static web page on the wrong screen. All right. So first things first, I'm going to go through, and we're going to actually look at this GraphQL backend stuff that I'm talking about. So, and yes, I want to make sure no one thinks I'm a shill or anything. I work at Hasura right now. We build this GraphQL API that works against Postgres right now. We have preview out for MySQL. So if you go out and get the latest version, you can play with MySQL. So you can have a Postgres database and a MySQL database. And shortly, probably within weeks, maybe a month, maybe 2 months, probably not 2 months, probably just a month or so, we'll actually have SQL Server support. So 3 different databases that you'll be able to play with. Here is the main site. And there's a cloud offering, which I'll talk about in just a second, where you can go in and you can create a database and a whole GraphQL API. And it will actually let you use a Heroku database, so you can use a free database. But what I'm going to show you is some of the stuff that I've set up. Give me just a second. I'm actually pulling it up because I didn't pull it up beforehand. I have a couple of things here that I'm going to show you how to get a Hasura GraphQL API endpoint up and running to use. So I'm going to show you those 3 things, then we're going to use the API endpoint a little bit. If you go out to GitHub, and I have a slide deck, which you see there, and all these links, they're in the slide deck, and I'll share the slide deck out so everybody will have all these links and stuff. So you don't have to worry about like taking notes or anything. Whoops, that's not how you spell GitHub. There you go. If you go out to my account here to Adron's ecosystem, this is where most, like 99% of the code that I'm going to show you tonight, it's all out here in this repo. And what I'm going to do first is I'm going to show you my dev setup. So this is just a completely local dev setup of Hasura. So let's see here, code. It's on the wrong screen. 1 second, moving things around. There we go. Okay. So I have dev start shell, and I also have PowerShell. So if you want to run this on Windows, you can do that too. I think this is broke though. So if anybody's a PowerShell guru, I'd love help with that later. But anyway, what we have is the shell script for the development environment. Again, it runs Docker Compose, spins up 2 containers. One's the database, one's the Hasura server. Then I have Terraform and NET. That actually creates the database, then takes just a second to make sure that the Compose and everything is up and running, and then deploys that database to the server that's just been deployed in the container, so that I have like basically, so I have the same database name. It's completely new though, so I don't have like any outlying configuration or anything odd sitting out there. And if we scroll down and look at PGDB, you can see the specifications of the database that's being created. So I take in variables for the username and password, set the port. It's going to be a localhost database, and etc. So it's not a real complicated one. It's literally just like if you have a database and a database server and you go into one of the management interfaces and you right click somewhere and hit new database, that's all this is doing. And it creates a database that's called, I believe we look back at that script, it's called Logistics Core Systems DB. So that's it. And these two username and passwords, that's just simply being pulled from an environment variable. That's what that fun syntax is. So if I type dev start, and boom, I'm up and running. Okay, so that started the two containers. If we do Docker PS, boom, you can see both of those. And again, one is the Hasura GraphQL endpoint, version 1.3.2, just to be specific, and Postgres version 11. You can use pretty much any of the last like 4 versions plus the latest one. I just used version 11 just because I put that number in the config file. That's the only reason that showed up. The Docker Compose looks like this. And the weirdest part of this is this hacky string here. I shouldn't call it hacky though. It just has the password put in right there, but it's basically your standard URI Postgres connection string. So that is those two parts. And then we're going to dive out here. If I go out to localhost 8080, we can look at the actual Hasura server. The cool bit here is right now I can start writing whatever GraphQL I wanted to. I don't really have anything set up in the database yet, but it gives you this interface to write that code here, gives you the endpoint that when you're writing code like C# code or JavaScript or Node or whatever it is, that's your endpoint to execute GraphQL queries against. But since we don't have anything in here, let's go check out the data section. The cool thing about the Hasura server console right here is you can basically build out your entire database from this interface right here. Like if I wanted to, I can just go in and create a schema or whatever it is I want. There's another feature that if you use the Hasura CLI, you can actually get migrations out of this. And I will show you how to do that. And I'll show you the little tricky bit that shows up when you do this. So if I go in here, you'll see I have a folder called migrations. I'm going to go into that folder. And I have a bunch of existing migrations. So I'm going to actually say migrate, Hasura, migrate, apply. And this is a basic schema migration tool. So when I hit apply, it's going to go out and apply all the migrations, which now that I did that, I just remembered. Let's check. All right, there's all the versioned migrations right here. And the config file, the config YAML actually points it at the database that you're running the migrations against. So I actually have it pointed out at my public facing one. So it already had the migrations applied, so that's great. But I want to run it against localhost 8080 instead, because I want all those changes applied to my database here. So let's do that. Again. And now if I refresh, there's my logistics database and all of my tables and such. So one of the interesting things about this, so I have all these tables now that are out there in the database, and there's also relationships. The difference is right now, I'm not tracked. Hasura can track all of these things so that it knows all of the relationships and the context and can apply the correct GraphQL correlation between all of the entities that you have with all these things. The easiest way to do that, just like the schema migrations, is to apply the metadata migrations. So I'm going to do that, Hasura metadata, oops, apply, and let that work. I'm going to refresh again, and you'll see all these things bounced over here. They're tracked now. So we got all that in there. Now that's pretty easy. I just ran it. I had all those things pre-built, but I'm going to show you how to make a migration now. This is a really cool part. So take a note, mental note here. This is running localhost console data schema logistics. It's running currently at that endpoint for the live executing containers, right? Now, if I go over here though, and I write Hasura console, it launches what appears to be the exact same interface, right? But if you look up here, I'm running against port 9695. What it has done, it has launched this console to initiate a workflow so that any changes that I make in this console are tracked locally. So if that other server that I was just talking about is one that's out in Azure or out in AWS or out somewhere publicly or out on a different server, you can still run this against it locally, and it will track all your migrations and your metadata. So like you see, I have all those tables that we just added, but let's say I want to add another one. I go in here and I'll just say, let's create a schema actually. New schema stuff. Let's create the schema, and then I'm going to create a table in that schema. So we'll have a new table, whatever. Make an ID. And you see there's a bunch of autocomplete and everything. So that helps a lot. There's that. I'm going to make the ID the primary key, and then we'll just name some text. I don't know. We'll add that, and then let's do a timestamp. We'll call this the stamper, and then timestamp, and the now function, and that should give us something to play with. So and then add table, and boom, there it is over here. In addition to that, it has all the interface elements where you can go in, you can insert stuff like me. Let's do another one. Let's say Sal. And if you browse, there we are. We've been added to the database. So the date stamp has been applied, ID over here, etc. Now there's a bunch of other stuff that Hasura can do too. You can set up actions. You can set up remote schemas. Remote schemas are basically, you can point it at another GraphQL server or a REST endpoint or something like that and draw out all the relationships from the data that's available from those APIs and relate it to data that you have in the Hasura server, so you can kind of bridge together all of your things, all of your data to a singular endpoint to use GraphQL against all that data. Pretty powerful. All right, so and then let's go look at what we just did though, because that's running. And if we look in this folder here, which looks like a mess, sorry about the darkness of this thing. I realize it's a bit darker than it probably needs to be. But these are all the migrations that have been created. That we ran earlier, and you'll see that the two new ones, new schema stuff and the new table, whatever, were created. The up SQL file, which says create schema, the down SQL file to drop it whenever you want to remove those things and move back and forth. And then the same for the actual table, new schema stuff, new table, whatever. So that's the migrations and the basic Hasura interface and some of the capabilities that it gives you out of the box. The GraphQL, the GraphQL, notice the little I in there. This is built into our interface. However, it is an open source tool. So you can go out and you can actually get a standalone app that you can point at any endpoint. It doesn't matter. And it will execute GraphQL queries against that endpoint for you. And you can also add header information. So like if you have auth0 or Okta or something like that that you're authenticating against, you can change all the header information to execute GraphQL queries against those things. But what's cool about this one that's not particularly available in other GraphQL stuff is the Explorer over here gives you all types of pre-introspected information about your tables, the table structures, the keys, and all that kind of stuff. So as you can see, we got like the Let's here scroll down. Here's our new table. And you can see some stuff like by PK. So those would be faster queries that are executed by a where clause that's specific to the primary key. And you can open up any of these and say, like, I want laden weight, load, mileage, name, and whatever else. And as you can see, it's requiring the ID. So you'd have to have the weird, unique ID, whatever that would be. And I filled it out over here, but you can fill it in here, and then it makes sure that the GraphQL syntax is actually correct, so you don't mess it up. And then you can run it, and boom. Of course, I have a data exception because there is no key, especially no UUID that's as a semicolon. Blah, 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 blah. So that's the GraphQL interface. Let's actually look at one that executes correctly, though. Boom, boom, boom. There's a nice one. So don't currently have any data in the database because, of course, we just created that database. The Terraform literally made that database brand new and inserted it into the container that started up. So, of course, there wouldn't be anything there. But this gives you an idea of how easy it is to write a GraphQL query that then you can, of course, take this, copy and paste it into whatever language you're using, whether it's C#, JavaScript, or whatever, and you have a functioning GraphQL query that you can then execute. You don't have to worry about the syntax and stuff because it's been built right here for you. All right, let's see here. Now, next thing I want to show you. That is local dev, basically. You can do a lot of variant, different type of stuff locally, but of course, you don't always want to just keep running everything locally. You want to eventually deploy the sucker. And I have a script for you, prod start. Now, of course, this next example is inclusive of the idea that you have a Azure account and you have set up the appropriate connection details like the keys and other things to be able to execute stuff against the cloud and get things deployed out to the cloud. So right now, I'm running this script, and we'll dig through it here in just a minute, and I'll show you everything that I have it doing. But I want to get it running because since it's doing a real production deploy out to Azure, it'll take a minute or 3. So let that think about what it's doing. I believe it should have just started. So we'll pull it up in code again. All right, so the production script, where did it go? Where did I do with it? Ah, there it is not really much more complicated from the script perspective. Literally, I move into the Terraform directory, and then I run Terraform apply, auto approve, pass in the environment variables for the username and password, and I pass a database, a server name, and the API port that I specifically want open for the console on the production server. I got to make one little caveat here. If it really is a production server, don't have the console turned on. That's a good thing to actually turn off. You don't want that on a production server. But this is a, kind of a mythical production server. It's real, but it's not really all that production. All right, so that's the script file. Super straightforward, just does that one call to Terraform. But the main.tf is where all the good stuff is done. So here's the connection provider to Azure itself. I create a resource group within Azure. Then the actual Postgres server is launched inside Microsoft's Azure. I guess they just call it Postgres service, but it's kind of like, it's a service that has multiple types of databases. You can use MySQL, you can use Postgres, you can use other things. And it's generally for relational databases. They have other services for other types of databases, but this particular one is Postgres, specifically the Postgres service. And it's just launching the server, not doing anything really out of the norm. The one big thing that you get kind of out of the box with the deployment here, you can see the backup retention days, 7. So without doing anything on your behalf besides setting this one value, you get 7 days of backups, which is kind of pretty cool. There's some other things you can do. You can do like geo-redundant backup enabled, yes or no. If you set it to true, it is much, much more expensive, because as it is, this is like $50 a month. If you do 2 regions, it's going to be twice that much, so 100-something bucks a month. And be careful with auto grow too. If you start dumping a lot of data in there and it blows up and gets pretty big, you can actually start to see some priciness there. But anyway, so that's the database itself. Be sure to enforce SSL. You want to make sure your pipeline is secure. Then this is a specific feature to Azure where you have to open up the firewall between the database and what is eventually going to be the API Hasura server. So that's opened up so that they can talk to each other from within Azure itself. So none of the communication goes out into the cloud and then back into the cloud or anything weird like that. It literally talks server to server instead of a roundabout. Oh, and I highlighted the wrong thing. This is the firewall setting. And then this is the actual database, kind of like what that other script did locally. This does to the production environment and actually gives me that logistics core something database, whatever I gave the name for. It's that specific name for that database. So then the firewall rule, like I was saying. And then we have the container group, which barely doesn't fit on the screen. So anyway, the container group is created. It's added to the resource group. It states that there's going to be a public IP made available for this particular container. Then the container itself is pulled. Here's the image. So that's basically the image name that's going to be out and available on Docker Hub. So it pulls the image from Docker Hub and then spins that up in Azure's contain, I guess ACS, Azure Container Service. Yeah. I always forget all the 3-letter acronyms they have on Azure. There's so many of them. And then I assign a little bit of CPU, a little bit of memory. The actual Hasura server, just so you know the innards of it, super fast, crazy, crazy fast. Largely because it is written in, you ready for this? Crazy drum roll. Haskell. That is correct. The backend is written in Haskell, so it's ridiculously fast. And thus, you can run something pretty decent on half a CPU and just a little bit of memory there. Then I assign it also the specific port I want, in this case 8080, and then again have a crazy connection string here. You can see like some of the odd things here that have to be done is at this particular point of the interpolation of the concatenated string, you have to use the escape sequence to get an @ symbol, but then later in the string, you can actually use the @ symbol. That's just some weird HTML, HTTP, crazy Postgres nonsense about the connection string. Other databases like MySQL, it would be different. It'd probably be a nice little clean string. And when SQL Server is available, it'll be your basic, your SQL Server connection string. And then some environment variables, and that's it. I have one thing that I did add here, this output variable. I added this for one specific reason. I am lazy. I don't want to open up a browser after I've run this script. So when we go back over to the terminal, where I've just run this, at the very end, it actually spits back out the URI endpoint of where the console is. So I can copy this and then go to where I want to. And boom. Now I have a Hasura server running out on Azure with nothing built in the database. It's just an empty database. Everything's up and running. Like basically, if everybody here right now goes to this URI, I believe you should be able to hit this console. So if you want to go in there and go into data and create a table or whatever you want to do, play around with it a little bit. I love that on this particular version, you can see secure your endpoint. It's telling you to secure your endpoint because my endpoint is, as I've just told all of you to go play with it, wide open. So and then if I grab this though, I can also go into my migrations and run those against this server too. All I got to do is change the endpoint, save that. Oh, did I name something wrong? Probably named something. Oh, I don't need the V1 GraphQL in the end. There we go. Did anybody add a table or anything yet? Or did you get access into it?
I walked right into it. I haven't done anything yet, but yeah.
Nice. So with me doing all that, I should have all those bits. Yep, see, there's the new stuff, logistics, all that stuff has been added, including that new schema that we just created together, the new schema stuff. So all that's up there. It's all available. We can run whatever GraphQL we want to against it at that endpoint. So let's see here. I feel like I added data to that weird table we just made, right? Trying to think of something kind of like an example piece to use. Where'd it go? Wasn't there? Oh, here's the table. Yes, please track it. Yeah, there it is. But we didn't add anything here. Let's add something here. I'm going to add me here. Just to have it, go to the GraphQL, and then give me a query of it. ID, stamper, name. Okay, so there I am in the database. We know I'm there. All right, one last example of deploying a Hasura GraphQL endpoint to play with. You can go out to Hasura. Let's actually go to the web page. And if you just click on like try Hasura or log in, it'll send you to sign up. And you can sign up, and it's a free account. There's a whole free tier, and you can run up to 5 servers if you want to. So that's pretty sweet, being able to run that many servers. So you don't have to just have one. You can play around with multiple ones. And then for the back end, I'm actually going to have a Heroku account, which again, this is a thing you can go sign up for free. Salesforce owns this, so I'm sure they'll probably just, it's like a loss leader for them or something like that.
Your first date's free.
Yeah, exactly. After that. Oh, and as we can see, I have some databases. I haven't cleaned up after myself for a while. What a mess. What a mess. But anyway, you can get up to 5 databases for free. Now, it's important to note that this is free stuff, so you get what you pay for. These things do go to sleep. So when you navigate back out to them, it may take a minute or two for it to wake back up if you haven't done anything to it for like a day or two. But the really cool part, like let's say you're out there and you're like, all right, I've signed up, I log in. This is basically the interface you get. This is one API endpoint that I have set up for myself, but it's as easy as hitting new project, select free tier, new stuff. Then I'm gonna pick the region. Let's go with Ohio. No, we're gonna go with California. That's way closer. Oh, I have to pay for California. Never mind. We'll go with Ohio. That's the free tier one. And then database setup. Just click on try with Heroku. Click it. Takes like 2 seconds. Builds another database. Then create project. And it's almost done. I think this takes like 10 seconds. Yep, almost there. So anyway, this is an easy way to set up a Hasura server with 0 Terraform, 0 scripts, 0 configuration, nothing. Like all you got to do is go and click on the buttons to get a whole server running, and you have whatever database you want to build out at that point available at this GraphQL endpoint, right? And it's the same as what we just did. You can go in, you can run it, you can build migrations, run migrations against it. You can go into the interface right here and add whatever you want. So, build out your whole database and just have fun with it. This is also by proxy a great tool to use if you want to learn relational database modeling and you want to learn GraphQL. This is like an easy, free, quick way to get started with this stuff. A few clicks and you have a server that has both things available for you to use that you can learn from or build off of, whatever you want to do. All right. So with all that done, we've got all our deployments out of the way now. Let's look at that. Yeah, vast wave 84674 is my new fancy database. All right, just let me clean up my mess here just a little bit. Okay. Now, the next thing I want to talk about is kind of the examples that I've been working from. And we'll actually get in, we'll look at this and then we'll get into the slide deck and look at some of those specific things. So I dug up this example out on the GraphQL.NET website. It's kind of tricky out there on the internets doing the Googles. When you search for GraphQL stuff, if you already have a server set up like Hasura, it's important to kind of search specifically for GraphQL client code, because otherwise you'll end up dropping into blog entries and all these examples, and almost every one of them starts purely with, here's how you build a GraphQL server. Because logically you would need a server first to run any GraphQL client code, but a lot of the times the examples and everything out there on the web are often very skimpy on the actual client code. So I dug up this client example, which seems like the leanest, meanest, simple example you could build, and it's kind of perfect. And I started building it out a little bit more because I'm going to add more classes for the models that I'm trying to pull back from the GraphQL entities and everything. But their example is a nice nested example of person and films response. Then you have person content. So wrapped inside of the person and films response is the actual content class. And then inside of that, they have some actual nested stuff for the relationship items. So the primary key to foreign key related items. And in this case, it's the person content, like the star of a movie related to the movies that they're in. And then they actually have up and running a live API endpoint that you can execute against. And if we run it, it's going to execute this GraphQL query where it asks for the person based on an ID. It gets the name, and then it gets the connection, the films that are connected to the person, and prints out the title of the films. And this ID here, we'll find out what that ID belongs to here in just a second. So if I run it, it's the ID of Star Wars, because, you know, if you're not doing foobar, you're doing a Star Wars example, right? So, and there's the movies that are related to Luke Skywalker, just like that. So you get this JSON blob back. And as with many things these days, GraphQL works in JSON. It basically speaks default JSON, JavaScript object notation in everything it does. So you give it the queries in JSON, you get back responses in JSON. So in the last little tidbit of this, which is going to tie together in an interesting, weird way, like most of the things I talk about. Shall I do presentation view? What the heck? I don't have notes anyway. So I've been looking at, and yes, if you're curious, this is kind of a complete disconnect from the other stuff, but I promise I'll tie it back together. I have been looking at cross-platform user interfaces in .NET for personal reasons, production reasons, business reasons, etc. I myself run Mac, Linux, and Windows. I have a machine for each, and I always try to keep as versed as I can pending on the reality that I don't exactly have that much time. I think we'd have to have like 96-hour days to really pull that off. But I try to stay as versed as I can in what's available to do things across these different platforms. And I looked recently, because of my love for C# and having used it so much in the past, I looked recently, I was like, all right, what kind of cross-platform options do I have these days that I can run, that I can build an app, hopefully as minimally as possible, and run it on my Mac OS machine, my Windows machine, or my Linux machine. I want it to run on any of them. If it runs on anything else, that's awesome too. I'll be happy if I can run it like on my phone or something. So the first two I ran into is Avalonia. Avalonia is pretty neat. It's a single, like when you create a new project, you get a single project, and that's it. That's pretty cool. And it detects what operating system it's running on and runs the app based on that. And it's pretty much standard XAML. So you get all the XAML components, all that kind of jazz, and you get a native OS running application as an end product. Your CI/CD build might get a little weird, trying to get it to build out the specific executables for each platform. But at least from a development perspective, very simple and straightforward in the sense that you have the single project with the single place to make edits to your user interface and everything else you're doing. And of course, you can break it out to an MVVM pattern or something like that if you needed to, but you start out simply and it gives you that good base to start with quickly to build something. Then the next thing I've looked at is the Uno platform. This one is kind of easy to get started with quickly, but what you start with is pretty vast. Like you start a project and you get what do they call it? A UWP, which is like Universal Windows something interface. I forget what the acronym is. Again, with the acronyms. But basically what it is, it's an app that can mostly run on whatever OS. But you also, in addition, get a project that builds out for iOS, Android, used to be Windows Phone. I think it still builds one for that, even though I don't know what it's going to build to. And then one for each OS. So you get a GTK for Linux. You get a WPF for Windows. So it's a very Windows specific one. And then I forget what the Mac OS one is. I think they just call the project Mac OS, but I forget which underlying library it uses. I think it has something to do with some of the Xamarin stuff. And then there's a central library project and then the user interface project. And in that, the user interface project is the single place where you build the actual user interface in XAML, and all the other projects build that XAML for the specific operating system or mobile phone that it uses. The easiest way to build an Uno project is to use this. Just use the .NET CLI. There is a way to get the templates into the IDE, like if you use Visual Studio or if you use JetBrains Writer. However, I would go this way because I've had weird issues depending on like where you start with the template on which operating system. You may or may not have issues getting it across different places. It seems like the safest way to make the most consistent starting template is just to use the CLI. Then some installation docs. Again, I'll get you the link to this slide deck because it's got all the good links and stuff. And then Avalonia, same thing. Highly suggest you use the CLI to just create a .NET new, do this, and then open it up in Visual Studio or whatever you're going to use to do your development in. The docs for that. The GraphQL libraries. So we just looked at GraphQL.NET a minute ago, and that is part of the GraphQL.NET project, which you see here listed as number 1. However, there are other projects to use. One of the ones that I've heard a lot of positive about is Chili Cream and Hot Chocolate, which of course, I love the name right off just because the name just sounds fun. But the other ones are quite interesting too. So like if you use Entity Framework, for example, and you already have SQL Server and Entity Framework all tied together and you got all those great objects and stuff, you want like a server API endpoint so someone can write GraphQL queries against it. Like if you got a web front-end person building stuff and they want to write GraphQL, you can use Entity GraphQL from Luke Murray. And basically what that does is it maps GraphQL, the GraphQL endpoint, to your entities in your entity framework, which is pretty awesome because then it cuts down on having to build like a whole separate layer just to connect to your database from a GraphQL server. That's pretty nice. So again, some options, and I'll get this slide deck to you. And also, I would again reiterate, use the .NET CLI to add those libraries because weird stuff otherwise. We talked about Hasura already, and we did all that stuff. And now I'm going to tell you about the project that I have just started like 2 days ago. I called it the Empire Builder. And this is a picture of the Empire Builder somewhere not around here. I believe that's in Montana somewhere. The Empire Builder is a train that runs from Portland and Seattle all the way to Chicago, if you don't know. And I called my project that, which I'm going to open up here. Where'd you go? Whoops. I don't know what I just clicked on. I guess I saved it. There it is, Empire Builder. This is JetBrains Writer IDE, by the way, just so you know what weirdness I have up here. And this is actually an Avalonia project. So you can see what that looks like. This is basically what you get out of the box. I have minimal additions to this, i.e. basically nothing. You can see the key capability of Avalonia triggering right here, though, in this code, where it says use platform detect. That's where it determines the OS and launches the application pertinent to the OS that you're running this on, which is kind of cool that it happens in code at this point. And then main window is welcome to Avalonia. And I run that. I'm on a Mac, right? So nothing special there. And then, okay, it actually ran the app, but it's on the other screen. So I'm bringing it over here. And you can see, boom, welcome to Avalonia. C# code running on a Mac, an application. So the reason I bring up that cross-platform stuff is what I'm doing is I actually have a database out there, and I'm starting to build out a project. And the Empire Builder isn't specifically about a train. It's about lots of trains. I'm building a database, and I'm going to build a cross-platform UI that enables people to query against the database to look at all of the rail systems, all of the shipping, the schedules for freight, passenger, and other transport in the US, Canada, basically all over the world. And I wanted to build a cross-platform interface for it. And that's what I'm starting to build here in this project. And it's out on GitHub too. So if anybody else wants to join me in that endeavor, I will be working on that in the coming days. But otherwise, that is all of the cool stuff that I basically had to show you. And did I close the slide deck? I did that. I didn't want to close the slide deck. I had 2 more slides to show you. Anyway, I'll tell everybody. The 2 last things I wanted to mention were Martin, I don't actually know how to say his last name now that I'm about to say it out loud, so I'm not going to. But Martin, I'll send a shout out on Twitter to him, but him and Khalid at JetBrains helped me out a lot in figuring out which front-end library I wanted to use for this upcoming project. And they also are big into the whole .NET side of things at JetBrains with JetBrains Writer and all that. But they're also pretty well versed in a number of other things like XAML, how to do MVVM, how to use GraphQL, all that kind of jazz. So big shout out and thanks to them for helping me figure out where some of those UI frameworks were, because it's not a simple selection these days, it seems like, because there's also a lot of Xamarin options. There's upcoming Windows UI options with the .NET Core like 5.0, some things there. It's kind of confusing. I lost track of what I ought to be using. So they helped me dig up Avalonia and Uno and look through those. And so far I'm going with Avalonia because it just seems like the simplest way to get a basic user interface going, to make a database available, to be able to do edits and do queries against it. And I'll make a website too, but right now I'm just working on the cross-platform user interface. So that's what I had to show. And of course, all that cool GraphQL stuff, the Hasura GraphQL endpoint server, etc. It's running in your Docker.
Adrian. Thank you. Are there any questions?
That's what I was just looking at. Oh yeah, I liked your insult endpoint. Any question? Anybody using GraphQL these days?
Not yet. We actually had somebody present on some aspects of GraphQL. I haven't quite figured out what I want it for.
Yeah.
I don't
But
see him here. I was hoping that our last presenter on GraphQL would be here for this.
I've read a little bit on the why it was what problem it was solving that REST typically didn't. But
right. The biggest one is it lets you actually, like in REST, you're always dealing with basically one piece of data at a time, or very, very single table specific, right? But with GraphQL, you can kind of arbitrarily define things you want across many tables or many entities, as would be called in graph lingo, right? And that's very helpful. It does also present the case, just like if you're using the entity framework or in Hibernate or whatever ORM or whatever tool against a database, you still have to. This is one of the things that always kind of frustrates me and always has made me end up learning database and front end stuff at the same time. Because even if you have this nice, clean GraphQL JSON object, right, that says I want the name in this thing, and then I want the related movies, but I also want the related other people and the related producers. Next thing you know, you've actually created a query that's going to have 5 joins and just kill the performance on your database, and it's going to be super slow. So you still none of this stuff, GraphQL, entity framework, all this stuff that makes it easier to write this code on the front end, none of it has ever kind of solved the easy ability. Once you make this stuff easy, you make it easy to write queries that just destroy the server and don't process well.
that actually leads into one of the questions that I did have. So that makes me glad to hear you recognize that right up front. Because you mentioned an ORM, and from what I'm seeing, what's it called? Not Heroku.
The Hasura?
Sounds like it's acting almost as an abstraction layer for all these different SQL backends.
Yes.
Or database backends.
Yeah. It's also, to put it in the most, I guess in the most terse, direct way that I would say is GraphQL is the most modernist way to build your middle tier data layer, right? It used to be take, for example, I don't know, when was it not normal to build web apps, or when it was weird to build web apps and you still build everything for Windows or whatever? Back in those days, whenever that was, 20 years ago or something, you build a middle layer, but it was in, you'd write it in whatever code, and it would be your ORM, your object relation mapper, but it would be considered your data access layer, blah, blah, blah. And it had all your business logic in it. But it was basically in a compiled thing that your Windows app would use to run against the database, and it would connect via whatever ways that connects. But then with all this advent of web stuff and all these 1,000,000,001 frameworks, some of that model started to come across, right? People people made ORMs for the web too, and used direct access methods to databases, which don't work well on the web, especially when things get massive, right? Facebook, after just a short period of time, they couldn't use a relational database for what they were doing anymore. They needed something else, which is one of the reasons why they originally wrote Apache Cassandra. They needed something that could scale accordingly. So they have those things, and the relational databases became a non-viable option for most of the web world that scaled that big. And again, Facebook then had some people write GraphQL based on that, right? On the ideas that this data is across disparate sources. And the nice thing about GraphQL is it works very seamlessly just to put it right on top of a relational database. But the real premise of its use is to kind of bring together data and get just the pieces you need, nothing extra, from not specifically a single source, but maybe disparate sources or something. Thus, what Facebook, created it for. And that's one of the things that I really like about it. But it in many ways, it's basically your data access layer. That almost sounds like I'm simplifying the whole thing, but that really is that's what it's acting out as. So yeah, that brings up the question too. It's like, do you want to put it into a .NET app? Would you want to? I guess it would kind of depend on what else you may want to have access to that data, right? Yeah, because
so I'm still pretty new to GraphQL. I haven't actually tried implementing it.
Mm-hmm.
So I'm trying to wrap my head around it. But the takeaway that I get as somebody new to this technology is that it's kind of a replacement for RESTful endpoints in a way. And so instead of retrieving discrete pieces of data as you would through a REST type endpoint, you would hit a GraphQL endpoint instead and use their query language to retrieve data from it, basically, is what you're saying, right?
Yeah. The other plus too is with the GraphQL endpoint, generally the premise is you build a GraphQL endpoint to connect to access to do all this stuff with, right? Matter of fact, in that interface, in the console interface that I was showing earlier, right here, you see the little post API endpoint, right? With GraphQL, every single request you're making, you're just sending a post, and then you send the JSON data in that post as data, right? So that's all you're doing from the HTTP perspective. Whereas with REST is often implemented in kind of a partial way, but the thing that is kind of universal across the board with most REST implementations, however deep you go with it, you're using a verb, right? You're using post, get, put, delete. Those are the main ones, right? To do CRUD. And also REST is focused almost primarily around doing just CRUD stuff. Whereas GraphQL takes that and kind of tosses the whole HTTP context and says, all right, we're going to move up a little bit. And all you're going to do is just send posts so that you can send more specific information about what you're trying to do, right? So in the case of that endpoint, like if I want to do a query, like we did a minute ago, what was that table? Oh yeah, this one. And I wanted to see, these three pieces of data. This is what's sent in the data with that post. That's it. And I can be more informative to the endpoint and thus just have one endpoint. So you don't have a bunch of endpoints floating around, like for the endpoint for this table and the endpoint for that table that are tied to a specific kind of relational object paradigm. It's a singular endpoint, and then you send the information that at the REST point is based on like the your path / whatever / object. Instead of sending it there, you're actually sending it in the data part of the post. So that's one of the biggest differences between REST and this. And it gives you the ability to, again, like I was saying, it gives you the ability to kind of provide more information about what you want back or expect back via that singular endpoint. Whereas REST, you're always dealing with a singular type of object context at any particular point. Like you're not going to, you don't do a query against two object points where you say, I want a list of these objects and a list of these objects, and then I'm going to join across it. You don't do that via the REST endpoint, right? You'd have to have a view in your database or something that already pre-connects those things to be able to have an object request against those endpoints to get a list of those things via the REST interface. Whereas with GraphQL, you can say, well, I want the stamper ID and name of table whatever, but if it's related to X, then you can add that ask within the thing here. Like if there was a relation, I can just say related table, whatever that is. And then in here, I can start listing out the columns in that table, right? Like name, stamp, date stamp, whatever, things like that. So,
Okay. Yeah. Very cool. Thank you.
yeah.
Yeah, it makes sense because I recall if a service didn't have the data that you wanted, you'd have to request it and hope the dev or service is willing to build it out for you.
Mm-hmm.
To spit
Exactly.
that data back out. Whereas with GraphQL, they can, assuming it's not protected,
Right.
it just gives it to you. Okay,
which they
cool.
can do. They can protect it. But
Right.
yeah, that's the whole security conversation, right?
I tell you another use case, by the way, is for
Yeah.
GraphQL. So at a larger company that I worked at, there will be a bunch of departments having their own API. Some departments would use another department's API for their own application purposes, whether it be internal or whether it be customer facing, whatever it is, right? And the thing is, like, these APIs were documented in wikis, right? And how to use them wasn't really clear because every department had their own way of documenting the API, so it was kind of annoying, right? And so so the whole company actually created a single GraphQL endpoint to consolidate all of these APIs. So GraphQL serves as a documentation, like as can be seen in the this Hasura GraphQL UI. Like you can actually see the IntelliSense popping in as you're typing out the like your queries, right?
Yep.
So that's really, really nice. Yeah, so they've been consolidating. And not only just consolidation, but you could actually define relationship between data, like documents, right? So that's really that's also really, really cool.
Yeah, you bring up something that I was just going to point out more specifically. Like the reason this Explorer works, and this is something that some people in the GraphQL community might scream at me for bringing up this thing and say, no, it's nothing like this, but it is kind of like this. If you remember way back in prehistory, with SOA and SOAP, there's this whole notion of discoverability, like being able to discover what a web service would have for you, right? Like what kind of data, what it does, what its purpose is, blah, blah, blah. One of the beautiful things, because REST did not really, it was just like, no, you just need to know how to access the endpoint, full stop. There wasn't a premise of like, I'll provide you information about what I have. Like there wasn't much of that ever in REST. There was some like weird hacky stuff that was added, but nothing really was presented. Well, GraphQL, one of the first tier concepts is being able to introspect against the API endpoint. And because of that, we have all this awesome IntelliSense, like was just mentioned, like I can hit control space. That's what I'm hitting right here. You see, and I'm getting all these queries. So like if I do a mutation, which would be something like an insert or an update or a delete, I type the mutation there, and then I can actually go over here, which is introspected and given me all my different options of what I have here. And let's say I want to insert, a new thing here. So let me add that. It gave me the syntax. And then when that inserts, which I'll just call it new data inserted. And then the response I want back from that is I actually want the ID that the database is going to create. Because if you recall, I said gen random UUID, which in the database just creates a new UUID for me whenever the record's created. And then there's the date stamp, which also uses a database function. So I want that back. Again, control space, stamper, and then insert that. Boom. It inserted it and returned that new ID and the date stamp back to me. So now, like if you're building an application, you can continue and add additional related things to this data or whatever. But if I just wanted to do a query now, open, close brace, control space, and then scroll way down and find this stuff. And then again, open, close brace. In that entity, I want the ID, and then let's get the stamp and the, what did I call the details? Control space, name. and then boom, there's that record I just added, right? And all of this is, if you go over here and I just hit Control Space, you'll see these options: query, mutations, subscription, fragment. And these things basically give you, like, query is basically doing a select query. Mutation is doing insert, update, delete. A subscription is something that REST definitely doesn't have. What a subscription is it actually connects via sockets and lets you basically be attached to something. So as data is added or updated in a table, you can have that subscription connected, and it will get you that data as it's updated, which is pretty awesome. But yeah, let's hear the query, and then you can actually write against the introspection. There it is. So I can introspect against the schema, and see that even the introspection is just available in the query language itself, right? And again, Control Space, I want to see, like, let's say I want to see my mutation types. Then I want to see the name of those. So basically give me a list of all my mutation types that I have available at this API endpoint. Run it, and boom. Okay, that's weird. I didn't expect that. But anyway, you get the idea. You run these queries, you can run the introspection queries, you can run all this stuff and get information about what's available at this API endpoint, which is a pretty powerful part of GraphQL. Kind of one of the selling points. If you're going to lift and shift away from, say, let's say you need to build a web interface for something, and traditionally it's been written in WPF or WinForms, or, hell, let's say COBOL or MFC 6.2. You have the database still, but really you need to attach a new front-end endpoint. And if you're going to go with the web, GraphQL is a great way to go, because you're already natively dealing with JSON objects, which the front end is going to have JavaScript. It's going to make it super easy to work with those objects on the front end if you're using GraphQL and you already by default have all this JSON. So great option in that situation. Cool. Any other thoughts, questions, comments? No. Everybody should go and sign up and try out Hasura. I want everybody's feedback. I mean, not that I'm telling you have to do this. I'm just saying I would love to hear everybody's feedback on the Hasura product. Feel free to direct it at me. I will put it all in my brain, and I will go and hang out with engineering like I do every day when they get up at 2 a.m. in their time zones, and all our different random time zones, and we will talk about all the stuff that y'all want. Then we'll make it happen. It'll be like magic.
We love magic.
We do. I agree.
All right. If there's no further questions, I'm going to stop the recording, and then the real questions can commence.
Cool.